Assalamualaikum. First of all, our today's topic is about pyrazole, and it is an important heterocyclic compound. First of all, we have short introduction of the pyrazole, that it is a bicyclic heterocyclic compound having three adjacent carbon atom and the two adjacent nitrogen atom, which act as heteroatom. For example, this is the structure of pyrazole. We have a nitrogen atom at the 1 and 2 position, while 3, 4 and 5th position are occupied by the three adjacent carbon atom, and the two double bonds are present in the pyrazole structure. First of all, a double bond is between two carbon atom, and the other double bond is between a carbon and a nitrogen atom. Okay, now at 1 and 2 position two nitrogen atoms are present, and then we discuss the occurrence of pyrazole does not occur naturally, it only synthesized artificially. Okay, we can't in nature this pyrazole is not present. We synthesize it in the laboratories by various reaction. For example, we add 1,3 dicarbonyl compound into the hydrazine to form pyrazole. Okay, then we discuss the IUPAC name of pyrazole. It could be 1,2-diazole. Okay, why we call this 1,2-diazole? Because at 1 and 2 position two nitrogen atom are present, and we have discussed that for nitrogen atom we use as a in IUPAC name. For nitrogen as a word is used, so we have two nitrogen atoms, so therefore we call it dia as a, and ol is added because it is a five member ring. We have discussed that if we have a 5-member ring, then we give it name as ol, and if we have 6-member ring, then we call it as ine. Okay, for example, pyrimidine. So last three words of the pyrimidine is ine, so therefore it is 6-member ring, so therefore it is called as pyrimidine. Okay, now in pyrazole we have 5-member ring, so therefore we add ol as its suffix. The IUPAC name of pyrazole could be 1 hydrogen pyrazole, because at one position a hydrogen is present, and then we called it pyrrole. Now we discuss the molecular formula of pyrrole, which is C3H4 and N2. We have discussed that at 3, 4 and 5 position 3 carbon atoms are present, and 1, 2, 3 and 4 hydrogen atom and 2 nitrogen atom are present, and this will become the molecular formula of pyrazole. Then we discussed about the structure of pyrazole. This is the structure of pyrazole. We have seen this is the carbon atom, this is carbon, this is nitrogen, this is another nitrogen, and this is carbon. First of all, we have said that the nitrogen atom has one lone pair on it, so this nitrogen has this lone pair present on it, and this nitrogen has this lone pair present on it. This nitrogen atom has one electron which evolved in the molecular orbital, or but its lone pair is free. Its lone pair does not take part in molecular orbit, but nitrogen number 1 lone pair take part in molecular orbital. So the nitrogen number 1 is similar to pyrrole, because we have discussed that in pyrrole the nitrogen pi electron take part in the pi molecular orbital structure, and its lone pair take part in the pi molecular orbital. And nitrogen number 2 is similar to pyrimidine, and we have discussed in pyrimidine its lone pair does not take part in the pi molecular orbital, so therefore we have said that pyrimidine is more is basic than the pyrrole. This is the major reason behind it, because pyrimidine lone pair does not take part in pi molecular orbital, its lone pair is free, so therefore it can easily react with any other one, and therefore it acts as a base. Because we have seen, if a compound has basic nature, then it's mean this compound has ability to gain a group from another compound. So therefore pyrimidine has a free lone pair. Its lone pair has ability to form bonds with another carbon atom, so therefore it has more basic nature. If we see pyrrole, in pyrrole we see that its lone pair present on the nitrogen atom does not involve in the pi molecular orbital, so therefore its lone pair is not free, so therefore it can't be able to form bond with another carbon atom, so therefore it is weak basic than the pyrimidine. So this is the major reason behind it. So therefore in pyrazole structure, one nitrogen act as a nitrogen of pyrrole, while the nitrogen number 2 act as a nitrogen of pyrimidine. Okay, and it's nitrogen number 2, it act as a pyrimidine nitrogen, because its lone pair does not take part in pi molecular orbital, and this pi electron is free for the attachment of other groups of the compound freely on the pyrazole. Now we see pi bond formation in the pyrazole. Two lone pair electrons from nitrogen atom. Nitrogen atom number 1, we have see in nitrogen number 1 we have two lone pair of the electron which are involved in the pi molecular orbital, and the one electron from each 3 carbon and one nitrogen atom of carbon number 2. One electron from the nitrogen number 2, one electron from each carbon atom, so therefore involved in the pi molecular orbital. So we count 1 2 3 4 5 and 6, so therefore 6 pi electrons are taking part in the pi molecular orbital of the pyrazole. So these 6 electrons form pi molecular orbital of pyrazole, and these 6 pi electrons make pyrazole aromatic. So we can say that our pyrazole is aromatic, it obey Huckel rule, so therefore it is aromatic. What is Huckel rule? Huckel rule formula is 4n plus 2. Okay, so in this compound n is equal to 1, so therefore when we put n is equal to 1 we get 1. 4 into 1 plus 2, it will is equal to 6. So therefore we see that a molecule with 6 pi electron could be aromatic. So we see that in pyrazole we have 6 pi electrons, so therefore we can consider it as aromatic due to it obey Huckel's rule. So total 6 pi electrons from pi molecular orbital. Short-handed representation of pyrrole can be represented at this like structure. Now we move on to the next. This is the resonance structure will be discussed in the next lecture. First of all, we have to discuss the electrophilic substitution. Electrophilic substitution occur at the carbon number 4. It could be occur at carbon number 3, but carbon number 3 is less stable. So therefore, carbon number 4 is more stable. So therefore, all the electrophilic substitution reaction occur at the carbon number 4. First of all, we discuss nitration. In nitration, we use HNO3 and the nitric group attached at the carbon number 4, so therefore we called it name as 4-nitropyrazole. Okay, then we add up sulfonation. In sulfonation we add H2SO4 and then we heat it in the presence of pyrimidine, and 3-sulfonic acid and pyrazole is formed. Now we discuss halogenation. In halogenation we add halogen in presence of H2SO2. This compound name is hydrogen peroxide. So therefore in this present this compound is formed and the double bond remains same. Okay. Okay, so it will become 4-bromo-pyrrole. Okay. Now we discuss N-alkylation. Why we call this N-alkylation? Because the alkyl group present attached at the carbon nitrogen number 1. So how this happened? For example, this is pyrrole and it CH3 and I act upon it. Then this I group will release as the form of HI. Okay, and this CH3 group, this alkyl group attach at the nitrogen number 1 and form 1-methyl pyrazole. Okay, and HI is released. Now we discuss N-acetylation. We call N-acetylation because acetyl group will attach at the nitrogen number 1. So therefore this is pyrazole and we add acetyl chloride in it, so we get acetyl group on nitrogen number 1, so therefore we called it an acetylation, and the CH group is released, HCl. This Cl and the hydrogen present at that place will attack to the chlorine attack on this hydrogen, and HCl is released. Now we discuss the oxidation and the reduction of pyrazole. Pyrazole in the presence of H2 and platinum, it form pyrazolidine because its double bond vanish, and a hydrogen atom is attached with nitrogen number 2. So this structure named as pyrazolene. Now we discuss the oxidation. In oxidation we have a derivative of pyrazole, which is 1 phenyl and 3 methyl pyrazole. At one place a phenyl group is attached, and at 3 position a methyl group is attached. Now we cause the oxidation of this group in the presence of KMnO4. We have discussed that at methyl group, carboxyl group is added due to the addition of oxygen. In oxidation we add oxygen and remove hydrogen, so therefore we remove hydrogen from there, and we add oxygen in it. Whereas all the structure remains same, just there is addition of oxygen, and the 2 hydrogen atoms are released in the form of H2. H2 gas is released, and this structure named as 1 phenyl 3 carboxylic acid pyrazole, because at 3 position carboxylic acid is attached, so therefore it is called as 1 phenyl 3 carboxylic acid pyrazole. Now we discuss the medicinal uses of pyrazole. So this is the medicinal uses of pyrazole. First of all, it occurs as anti-cancerous. In anti-cancerous, the medicine which is used is named as dacarbazine. Okay, in dacarbazine medicine, the derivative of pyrazole and pyrazole ring is present, and which this drug occur as a anti-cancerous agent. So this is the important medicinal importance of pyrazole is given. Then the second important role of pyrazole is that it occurs as analgesic. Analgesic mean it can cause मतलब ये पेशेंट को बेहोश करने के लिए काम कर सकता है, एंड इट कैन आल्सो अकर एज पेन किलर. कि हम पेशेंट को जब भी बेहोश करते हैं तो इसलिए करते हैं ताकि पेशेंट को ज़्यादा जो तकलीफ़ है वो महसूस ना हो. सो इट अकर्स एज अ पेन किलर. सो इन पेन किलर फिनाइल ब्यूटाजोन, it is a medicine name, it is present, and in phenyl butazone a ring of pyrazole is present. It also occurs as antiviral, and it occur as a microbial, and medicine name is cefalocin, and it also occurs as antimicrobial agent, and due to its cytotoxic activity, because it can fight against our bacteria and our microbes which are present in our body. So therefore, if a bacteria attack on us, if a microorganism attack on us, if a fever causing agent attack on us, then it can fight against this agent. It can also occur as antipyretic. Antipyretic mean it destroys the pyrogens which are present in our body, and pyrogens are the agent which cause fever to us. They increase our temperature and make our body less immune. So therefore, if a pyrazole containing medicine given to a patient, then it can be a treatment of the fever. And it also occur at Terrazine. Terrazine is a medicine name in which pyrazole derivatives and pyrazole ring is present. And what is the role of Terrazine? That it is a yellow dye which is used for the food. It means that it is a color food, and we can use in for the coloring of the food. So this is the medicinal uses of pyrazole. All these are the medicinal uses of pyrazole, and this is the extra detail that pyrazole is also present in tetrazine, so therefore it can also be occur as a coloring agent of the food. So this is all about pyrazole. I hope that you will like it. Please like, share and subscribe this video, or stay tuned. Allah Hafiz.